Hi, how are you? My name is Adrian Turner, and today we're going to be talking about rare earth elements in Canada. So, first of all, this was a school project. It was a simulation game, and it was to start your own mining company, basically. And it prompts you with different questions, and you have to come up with responses and answers in the best way possible, and be environmentally friendly and also financially profitable. So, getting started with my company, here are the few goals that I want to obtain with my company, and that is having workers earning a good wage, so not pennies on the dollar, over a living wage. I would like to invest in new tech to discover deposits and minerals. I'd like to be an environmental steward, so this means conservatism, really caring for the environment, and replacing what we have taken or what has been lost through the process of the company. And yeah, preserving habitats and environments. So this comes with animals, the local people that live there. We want to keep their water safe, their habitat, and their trees safe. So the mineral I decided to mine was rare earth elements, and this actually contains 17 different minerals, and scandium is the most common. It has many uses in today's tech. It's absolutely crucial for phones, motherboards, semiconductors, LEDs, magnets. So anything tech, magnets, rare earth elements are in it. So I decided to base my mine in Canada, and this is just due to location, since we're going to be headquarters here. In Canada, there's low competition right now for mining of REE. There is a couple startups that happened in 2021, but there's relatively low competition. Innovation, Canada has the money, the technology, and just the education for the workforce to have an innovative company and practices. We have lots of land. Of course, Canada is the second largest country in the world, and lots of that land contains high REE, or rare earth element bearing deposits. So, Canada has a new interest, as I said. There are a couple new startups happening, such as the Nechelado mine, if I'm pronouncing that correctly. United States is looking for new imports, so currently China has a grasp on the market. It's over 60%, but of course the United States would like to import from different countries, and Canada would be a great replacement for that. We have large REE deposits, so especially in the Alberta shales. This is mainly due to the rock having high concentration of REE compared to other rocks. But in Canada, there are high regulation costs that come along with mining. That's for workers. Just the mine itself has to be its structural integrity. A lot of factors for regulations in Canada. So choose my mining method. So there's primary or secondary deposits. Primary is when the land has been untouched and you find that there is a rich deposit and you want to dig that up. That's primary. Secondary deposits can be from either the top rocks where you're not disturbing too much, you're not digging too much, or it can be from waste rocks from other projects such as coal. So that can be like the ash from coal, or say gold mining. a lot of that rock contains, the waste rock contains rare earth elements. But for my company, I decided to do primary deposits, and that's just mainly due to it having a higher concentration of rare earth elements. You can find that, and you don't have to rely on waste rock, although it could be a great potential option for other companies, especially for the environment. So, choosing the method of primary mining. So there's three methods. One is underground, so you're digging a tunnel basically and putting jousts to hold up each level. There's open pit mining, such as the Nechalacho mine, which is in Northwest Territories, I believe. It's an open pit mine, as you can see here. There's ocean mining, which is good for resources such as oil, which have a consistent flow, or diamonds, which one small find can have a high amount of revenue and profit. So overall, I chose to go with underground mining just because it has the least amount of impact on the environment, and ocean mining has a lot of complications, and it's not a great choice for rare earth elements. So these are the results of underground mining that the simulation gave me. So of course, underground mining is going to be better for the environment for the most part. That's because it's not actually disturbing the surface land, it's not destroying the trees or the animals. It's more so risky in the water situation and water tables, but it's overall better than an open pit mine. Underground allows you to get to rich ore deposits, same as an open pit would. It's just not as destructive, it's more calculated. It can require expensive equipment to do underground mining. That's just due to finding where the good deposits are, and of course drilling, digging, jousting, structural integrity, engineering, all the things that come along with that, and more regulation. Of course, as I said, with the structural integrity of the mine, it's a big problem. So, processing rare earth elements. I decided to process the minerals and rocks in Canada and not send them offshore. This is just due to Canada's regulations and me wanting to be an environmental steward. When you send rocks offshore, you're never sure how they're going to deal with it or what regulations and practices they have in place. They can be very harmful to the environment, and I don't see why we should transport them and waste our resources for someone else to do the job. So yes, I decided to process the minerals locally. Here are the following complications of processing REEs. The picture at the bottom here, it brings you through the whole stage of rare earth element minings, and at the bottom it shows you the concentration within the ores, which is actually very interesting. The original ore would only have a percentage of a max of 10% rare earth elements, and with physical beneficiation basically means you're not using chemicals yet, you're using maybe flotation, gravity, magnets, just to extract it physically from the rock. You can get up to 50% RE concentration, but then you have to use a lot of chemicals, acids, and these are the things that create wastewater and tailings, which we will talk about later on. So local processing promotes environmentalism. That's again because you don't know what offshore countries may be doing with the rocks and may not be uh, dealing with it with such care and diligence as a Canadian company might. Yeah, again, offshore is detrimental to the environment. And one of the other benefits of doing it locally is the fast logistics, the supply chain, everything is happening close to us. So if we need it for our phones or whatever it is, or United States wants to import it, everything is done here, and it's saving you transportation costs and taxes. So closing the mine, uh, here are a few of my goals, and I'm just going to reflect on my decisions throughout mine. Environmental stewardship. So first of all, we want to do it in Canada, which has high regulations, and that's protecting the local people and the local environment. Underground mine is protecting the environment, and as we go on, we'll see how else we'll protect the environment. But we want it to have fair wages and be blood free, so we're not gonna go offshore to where Africa might pay people dollars a day for dangerous work. We're going to be paying Canadians, or either importing workers from other countries and paying them a fair wage. We want to be profitable. We can't exactly see if we're profitable yet, but we hope to be. And yeah, all my decisions so far definitely align with the company goals. So closing the mine, and there's a few things that we got to keep in mind. Number one is tailings. Tailings are basically the acid and some of the chemicals from extracting the rock from the earth. As rain falls, that can wash the water into the water tables and it evaporates, creating acid rain. It's a very huge problem for rare earth element mining, especially because so many chemicals are involved. So Canada does have a lot of regulations around tailings and other and other waste rocks, but catastrophes do still happen. Canada is actually number 2 in having problems with tailings and runoff and leaching into water. They're number 2 next to China, or we are number 2, I should say. And the measures I'm going to take with my mine is backfilling. So the waste rock that I do have from the processing, I want to put it back into the mine. That's just to reduce dust, mainly. Venting, so this allows some of the gases that. So when you agitate the rocks, there can be gas buildup, sometimes methane, different things that have to be vented, and that's the process of venting that I'm going to do with my mine. So, I just missed a slide here. Sorry. Oh, some of the outcomes that can happen from having a good closure of mine is good press, first of all. So that can encourage news outlets to talk highly of us about our mine and how we didn't negatively affect the local communities of where the mine was. And yeah, just morally and ethically feeling better about our decisions and disposing of toxic waste smartly. And so conclusions are environmental stewardship. We've talked about it multiple ways throughout here. Underground mining, doing it in Canada, processing and disposing of things properly. good wages, paying Canadians or imported visa workers per se. We want to be profitable, and here are the few takeaways from the assignment. I learned a lot about the process of mining. Basically, underground mining, joisting, how mines can collapse, fail, leaching, tailings, a lot of things actually. I learned about today's tech and how rare earth elements play a huge part in today's tech, and really how we cannot throw them away, and how these things should not just be disposable items, really treat them with care and use them for maybe more than 1 year, because the components are coming from somewhere. So thank you for listening to my project, and yeah, have a good day.